How does destructive testing identify material types? Imagine trying to figure out what a mystery object is made of by smashing it open. That's essentially what destructive testing does to identify material types. It involves breaking down a sample to see what's inside and how it behaves under stress. When engineers want to know exactly what a material is, they push it to its limits. They apply forces or conditions that cause it to fracture, deform, or fail completely. This process reveals details about the internal structure, composition, and mechanical properties that are not visible from the outside. For example, in tensile testing, a sample is pulled until it breaks. This test measures how much force it takes to snap the material and how much it stretches before breaking. Different metals or alloys have unique tensile strengths and elongation rates. Hardness testing involves pressing an indenter into the material's surface to see how resistant it is to deformation. The amount of force needed to make an impression helps distinguish one material from another. Chemical analysis is also part of destructive testing. Once a sample fractures, scientists can analyze the broken pieces to identify the elements present. They might use laboratory methods like spectrometry or wet chemistry tests to determine the exact makeup. Knowing the elemental composition helps confirm the material type, whether it's a specific grade of steel or an aluminum alloy. This type of testing is especially useful when trying to understand why a product failed. It shows whether the material was weaker than it should have been or if internal flaws contributed to the breakdown. If a component breaks prematurely, destructive testing can reveal if the wrong material was used or if manufacturing defects were present. Although destructive testing destroys the sample, it provides definitive answers about what the material is and how it behaves. It's a key step in failure analysis, quality control, and research. By applying forces that cause failure, engineers can see the true nature of the material and use that knowledge to improve future designs. In short, destructive testing identifies material types by physically breaking the sample and analyzing how it fails and what it's made of. This approach helps explain why things break and guides better choices in materials and manufacturing processes.